Hello everyone, welcome back to our channel e-learning tutor. So in this 8th video of Super 5 series, we are going to see 5 challenging questions of chapter Trigonometric Equations. If you missed watching previous videos, I'll link it in the I-bar. You can check it out if you're interested. So it really means a lot if you subscribe. So please subscribe. Without any further ado, let's get started. So first see all the questions that we are going to do today. Well, trigonometric equations will run around these three formulas. Okay, first let's go through these formulas. When sine theta is equals to sine alpha, theta value will be in this range. Same cos theta will be in this range. Tan theta will be in this range with respect to alpha. Well, let's go to the questions. Okay. The number of solutions of the equation tan alpha plus tan x plus secant x is equals to 2 cos x lying in the interval 0, 2 pi. Okay, is how many? Number of solutions which satisfy this equation in this interval is how many? Okay, let's convert this whole equation in terms of sine and cos. Okay, sin x by cos x plus 1 by cos x is equals to 2 cos x. Sin x plus 1 is equals to 2 cos square x. Okay, sending this to right hand side. Now we know that sin square x plus cos square x is equals to 1, whereas cos square x is equals to 1 minus sin square x. Okay, let's apply it here. What we are doing is we are converting this whole equation in terms of sine. Okay, sin x plus 1 is equals to 2 of 1 minus sin square x. Sin x plus 1 is equals to 2 minus 2 sin square x, which imply 2 sin square x plus sin x minus 1 is equals to 0. Factorize it. Okay, what do you get? 2 sin square x plus 2 sin x minus 1 is equals to 0 obviously. 2 sin x common. What do you get it here? Sin x plus 1. Take minus common here. Sin x plus 1. Factorize. Done. Now 2 sin x minus 1 into sin x plus 1 is equals to 0, where sin x is equals to half and sin x is equals to 1. Sorry, here it is 2. Well, now see where theta is positive. Here. See, theta, of course it's x. Here and here. So what are the possible values for it to be 1 by 2? Sorry, here it is not there. Theta is x is equals to pi by 6 or x is equals to pi plus pi by 6. What is it? 5 pi by 6. Sorry, pi minus pi by 6. Here, right? So, well, now sin x is equals to 1. Okay. Where will sin x be 1? Here. Here sin x will be 1. Okay. So what is this value? 3 pi by 2. Okay. What will be the value of x? 3 pi by 2. Okay. Now what are the values of x that we have got? Pi by 6, 5 pi by 6, 3 pi by 2. Okay. Now what is the actual equation? Tan x plus secant x is equals to 2 cos x. When you substitute 3 pi by 2 in tan x, you'll get infinite. Right? So this is not possible. Okay, this is not possible. So the possible number of values which satisfy this solution, the number of solutions of this equation is 2. Well, So let's see the next question. Second question. Solve sin 2 theta plus sin 4 theta plus sin 6 theta. Okay. See carefully. We know the formula sin C plus sin D, right? So take these both and apply that formula. Why we are doing this? See, 2 plus 6. 2 plus 6, 8 by 2, 4. So we can take common and substitute it, simplify it. Yes, let's do it. 2 cos C plus D by 2. Sorry, 2 cos. What do we get here? 2 theta. Sin C minus D by 2, right? I'm sorry. Sin 4 theta plus sin theta. Sin 4 theta is equals to 0. Take out sin 4 theta common. Sin 4 theta into 2 cos 2 theta plus 1 is equals to 0. You have both solutions. Sin 4 theta is equals to 0 or cos 2 theta is equals to minus 1 by 2. Well, yes. Now we can write 0 as sin 4 theta is equals to sin 0. See this formula. Sin theta is equals to sin alpha. Theta is equals to this. So can we write 4 theta is equals to n pi because alpha is 0. N pi. What will be the value of theta? N pi by 4, where n belongs to integers. Okay, let's solve this. Okay, now we can write this thing as pi minus pi by 3. Pi minus pi by 3 value is minus 1 by 2. Yes, cos 2 theta is equals to cos of pi minus pi by 3, which is 2 pi by 3. So directly we can apply it. 2 theta is equals to 2. Okay, let's take m because here we took n, right? Let's take m plus or minus 2 pi by 3. Theta is equals to m pi plus or minus pi by 3. M belongs to integers. Okay, got it? Well, that is a solution. Theta values are those. Okay. Okay, let's see the third question. The number of solutions of the equation mod cot x is equals to cot x plus 1 by sin x. Okay, x is in the range of 0 to 2 pi is number of solutions possible. Okay, let's calculate it. What is the equation given? Cot x is equals to cot x plus 1 by sin x. 0 less than or x. This is the range, right? Is it? Yes. So let's go quadrant wise. In first quadrant, cot is positive. So mod of cot is also positive. Cot x is equals to cot x plus 1 by sin x. Cancel. 1 by sin x is equals to 0. Is this possible? Which implied cosecant x is equals to 0. This case is not possible. Not possible. So we will not get any solution in first quadrant, which means when x lies between 0 to pi by 2. Okay. So second quadrant, let's see. X belongs to pi by 2 to pi. Okay. Cot x is negative. Yes. Minus cot x is equals to cot x plus 1 by sin x minus 2 cot x is equals to 1 by sin x. Well, now we can write cot x as cos x by sin x minus 2 sin x, cot x by sin x is equals to 1 by sin x. Cancel. So what will be the value of cot x? Minus 1 by 2. Well, is it minus 1 by 2? Yes. Cos. When is it minus 1 by 2? Is the question. When will it be minus 1 by 2? When x is equals to 2 pi by 3. Yes or no? Yes. Now let's go to the third quadrant. Third quadrant. Cot theta is positive in third quadrant. Yes. Cot x is equals to cot x plus 1 by sin x. Cancel, cancel. 1 by sin x is equals to 0. We all know that this is not possible. So, not possible and no solutions will be here. Well, fourth quadrant. Theta is negative again. Minus cot x is equal. Same, we will get it as like this case. Cot x is equals to cot x plus 1 by sin x, which imply minus 2 cos x is equals to 1. Cos x is equals to minus 1 by 2. Again it is 2 pi by 3. So only one solution is possible. What is it? This equation is satisfied only when x is 2 pi by 3. Okay? Now only one solution. Yes? Now let's see the next question. Solve the equation cos 2x is equals to sin 3x. Cos 2x is equals to sin 3x. Okay, let's see. So can we write this in terms of sine? Yes, we can. What can we write it as? Sine of pi by 2 minus 2x is equals to sin 3x. Now it is in the formula sin theta is equals to sin alpha. Yes, yes. So we can apply this formula. Theta is equals to n pi plus, can we apply? See, exactly it is. So we can apply minus 1 power n into alpha. We can apply this formula. So pi by, so here this is our theta, this is our alpha. Minus n pi, sorry, 2 pi 2x is equals to n pi plus minus 1 alpha. What is it? 3x. Yes. Is it? Now rearrange it. Send this side and n pi to this. Okay. What do you get? Pi by 2 minus n pi is equals to 2x plus minus 1 power n into 3x. Yes. Now pi minus 2n pi by 2 is equals to x of 2 plus minus 1 power n into 3, where x is pi minus 2n pi by 2 into 2 plus minus 1 whole power n into 3. Yes, we can rearrange it as pi of 1 minus 2n by 2 of 2 plus minus whole power. Yes, so this is our value of x. You substitute any value of n, you will get the value of x which satisfies this equation. Okay, now let's go to the fifth question. Oh, this is combined question of quadratic equations and trigonometric equations. Well, let's see it. If alpha and beta are the roots of the equation k plus 1 into, okay, let's write it. K plus 1 into tan square x minus root 2 lambda tan x is equals to 1 minus k, and they gave the value of tan square alpha plus beta. They are asking the value of lambda. Okay, see the question very carefully. Okay, all are in terms of tan. So send this 1 minus k to LHS side. K plus 1 tan square x minus root 2 lambda tan x is plus k minus 1 is equals to 0. Yes, we know that sum of roots, what is it? Alpha plus beta. Yes, alpha plus beta. Tan alpha plus tan beta is equals to what? Root 2 lambda by k plus 1. Yes, minus of minus, it becomes plus. Product of roots. What is this? Minus b by a, right? So, well, product of roots, what is it? K minus 1 by k plus 1. What is the actual formula? K plus 1 c by a. Yes, see, look carefully. We know the formula for tan of alpha plus beta. What is it? Tan alpha plus tan beta by 1 minus tan alpha beta. Tan alpha tan beta. So we have all the values. Let's substitute. Root 2 lambda by k plus 1 by 1 minus k minus 1 by k plus 1. Let's solve it. Plus 1 by, what do you get it here? K plus 1 minus k plus 1 by k plus 1. What do you get? Root 2 lambda by 2. Okay, substitute root 2. See, multiply and divide by root 2. What do you get? Lambda by root 2. Correct. Now, this tan of alpha plus beta is equals to lambda by root 2. We got the value of tan square alpha plus beta is equals to 50. So, let's square it. Tan square alpha plus beta is equals to lambda by root 2, which is 50. Yes, tan square by 2 is equals to 50. Lambda square is equals to 100, which imply lambda is equals to 100. Yes, sorry, 10. Sorry. So, lambda is equals to 10. Let's see whether it is there in the options. Yes, it is there. So, these are the solutions we have done. Thank you so much for watching.